Okay, chapter 5. Here we go. So, the first little bit is going to be a quick review of some things you've seen before. I'm not going to go in depth on that because section D of this is going to be the most complicated part. So I'm just going to breeze through the beginning of this really quickly so you can see this. Difference of squares. So difference of squares is a neat little trick that you will need to be able to recognize. Notice if I just show you how to multiply this in the long way. So x times x gives you x squared. Positive 3 times x gives you plus 3x. X times negative 3 gives you negative 3x minus 9. Notice middle two terms cancel. You get x squared minus 9. So this little trick, the middle term cancels out if these terms are all the same except one's plus and one's minus. So I can do that here and just instantly recognize first two terms are the same, second two terms are the same, and 1 plus 1 minus. Instantly I know I can just multiply them out and get this. Square the first term, square the second term, you get the middle term cancels. So you should be able to also reverse engineer this. So if I give you x squared minus 16, notice I can take the square root of the first term and I can take the square root of the second term, and that becomes my two brackets. So I can square root this, I can square root this, so I'd get x for the first term because that's the square of this. The square of this is 4 and 4, one's plus, one's minus, and that gets you your term. So pretty straightforward. I can do that again if there's a little bit more complicated one, so something like this. Square root the first term, square root the second term, and you'll get what you want for this. So the square root of this, 9x squared, becomes my first two terms. Square root of this is 4y squared. One's plus, one's minus. There's your terms. So that's squaring, pretty straightforward. There's squares as well. This one's a little bit trickier to be able to recognize. So if I multiply this out, I'd get x squared plus 6x plus 9. So the key recognition with this to go in reverse is the square root of this term is doubled to get this term. Now that's tricky once you start getting terms up front here. That's why I'm not huge into this, being able to recognize this. If you can recognize at this point that there's something special about it, by all means do it. But I would expect that this, you would just do it the normal way I've shown before and solve it that way. Just because it's a little bit trickier to be able to recognize this. If you can, great. By all means, use that shortcut, but I'm not going to expect that. Then this is kind of like the conglomerate of all the factoring we've done. So you need to look at this and you first figure out, is there a common factor? You always want to check that first. It's going to make your life a lot easier when you move on to later parts. So in looking at this, let's try this one. I can notice I have a 5 I can factor it. So factor out the 5, we get x squared minus 8x plus 7. Then I factor this like normal. What two numbers add to negative 8? Multiplied to positive 7. Notice the 5 still stays here. So x minus 7 and x minus 1. And that gives us our terms. Simple as that. So always check to see if you can factor out a common factor to make your life a little bit easier. If you want to do these other ones, you can give that a try. But again, this is just combining the two things you've seen before, and I really wanted to get into this part. So mixing composite functions and factoring. So this one, you get into a little bit more complicated things. Because it looks quite complex with you've got some x plus 1 squareds and some x minus 1 squareds, and you could do this by actually squaring this first, squaring this first, subtracting them and figure out what to get. It just takes a lot longer to do that. So instead, what I would suggest is something that is called substitution. And you'll see this many times, especially if you get into physics 12. You'll for sure need that with me. And it's just a handy skill to know, especially in university. You'll use substitution all the time. So it's important to know. What I'm going to do is these brackets, you'll notice with all the questions here down to the end of the page, all of them have something in brackets. That's going to be the biggest indicator that you're probably going to need to substitute when you're dealing with factoring. So what I'm going to do is I'm going to say, okay, here's a bracket, x plus 1. That's difficult to deal with. Let's just call this A. This bracket is not the same, so I have to call it something else. Let's call it B. So in doing that, what I end up with is A squared minus B squared. Well, this should look really, really familiar because we just did this on the last page. I can simplify this really quick. If I can take the square root of the first term, the square root of the second term, that gives me A plus B times A minus B. I can do that. But I'm not done yet. That's the only problem with this one. I will need to re-substitute back in these terms. So A is x plus 1, so I need to put that back in here. So x plus 1 plus B, which is x minus 1, all times x plus 1 minus x plus 1. Notice this is plus 1 because I'm subtracting all of B, meaning it's minus x minus negative 1. So be very, very careful with that. So simplifying this, 1's cancel. I get 2x. In this one, my x's cancel, and I get plus 2. There's my answer. 2x plus 2. So that's what you're going to do with composite functions. You're going to find a substitution. You'll notice with this first example, these are all difference of squares. So you'll be able to do that. Let's try these other ones. So these more complex looking terms are not really overly complex once you do the substitution. So you'll notice here your brackets, they're the same. So I'm going to call it the same thing. Who cares what I call it? There is no, if you call it x, it's going to be a little bit confusing. So maybe try not to use x, but let's call this one w. Why not? So w, I'm going to substitute w in for x minus 1. So that gives me w squared minus 10w plus 25. Much, much easier. I know how to do this. So what adds to negative 10 multiplies to this. Hey, we've got a difference of squares. I know this one. So we've got w minus 5 times w minus 5. Or sorry, not difference of squares. This is just a square. I could write that as w minus 5 squared, as you like. I like it like this. So substitute back in. So we get x minus 1 minus 5 times x minus 1 minus 5. And we just get x minus 6 times x minus 6. This, it's hard to believe that it actually equals this, but it does. Let's try another one. So, actually I'm going to keep moving on. So these ones are just squares. Those are pretty straightforward, but let's try some of these. I'll do 2 of these ones. So I'm not even going to start with the first one. Let's start with the second one. Why not? Again, these brackets are the same. Let's substitute. What shall we use? I like the letter J this time. Why not? So we've got j squared minus 6j plus 8. Factor this out. What adds to negative 6? Oh, sorry, this is 8. What adds to negative 6 multiplies to positive 8. Well, that's going to be j minus, what do we got? Minus 4 times j minus 2. Substitute back in. So we got, instead of j, it should be x minus 1 minus 4, and then x minus 1 minus 2. We end up with x minus 5 times x minus 3. There we go. So that's our final answer. Always make sure you have the same variable as what you started with. Otherwise, it's going to be complicated. Let's do another one. Which one looks hard? Let's do D. Again, substitute. What should we call this one? Z. Sure. Z's are cool. So we've got 8z squared plus 14z. Although z's sometimes look like 2s, that makes it more complicated. Oh well. As such, this one, let's use the box. Let's try that one out. So make a box. I'm making the box really complicated way. There we go. So first term, 8z squared. Last term, negative 15. So I need two numbers that add to 14, and they're going to multiply to negative 15 times 8, and I gave myself a doozy to try and do. So let's see. 2 times 15 is 30, 120, I believe. Let me double check. So 15 times 2 gives you 30 times 4. I sure hope that's right. Okay, I think it should be. So what adds to 14 and multiplies to negative 20? Okay, I'm going to pull out my calculator for this because, like I said, you are getting the raw, uncut version. I do not have this example solved, or do I? Nope. Okay. So let's try it. Double check. 8 times 15. Thank goodness I did that right. That would have been embarrassing. Okay. So what two factors add up to 14 and multiply to negative 120? Well, I know that I have, they have to be a positive and negative answer, and some of you are already thinking that you know the answer, and therefore you must be smarter than the teacher. Touche. You might have that. I'm also recording all of Unit 1 in one go in a very hot room, so my brain is a little bit toast. So let's see. Add to negative 14, so I want us to be positive and negative. Let's just do a simple 26. 20 times negative 6. Ha! First try. There we go. Okay. To which you would say, you're the teacher. Of course you're supposed to get it in first try. You've done this for so long, Mr. Brandon, that it should be no problem. To which I say, teachers make mistakes. Especially on videos now that this is public for the entire world to view, of course you're going to see my mistakes. So, here we go. Let's, you get all my side notes too. Let's factor the columns and the rows. So column, let's figure out what's the greatest common factor. So I can factor out a 4z, and here I can factor out a minus 3z. And here a 2z, and here a 5, right? And so this should all multiply back in. Sorry, this one shouldn't have a z. See, mistakes. Done. Okay, so here we go. So we got 4z minus 3 times 2z plus 5, but we are not done yet. We need to factor back in this, our x plus 2. So this is going to get a little bit messy. We got 4 times x plus 2 minus 3, 2 times x plus 2 plus 5. The camera's still on there, good. This will take a little bit of steps. Multiply the 4 in there, so we got 4x plus 8 minus 3 times 2x plus 4 plus 5, and simplify inside the brackets, we'll get 4x plus 5 and 2x plus 9. Ta-da! There is our answer. So this one takes a little bit. Again, notice the box is actually quite quick, so hopefully in seeing that a few times now, this is starting to make sense, and you'll notice how fast that is as well. Okay, so is that, yep, that's the end. Again, if you want to try out the other stuff in the notes, you can, I will have those all completed. You'll be able to check that out. But that is this section. So see you in class.